So, ladies and gentlemen, please welcome to Sweden for the second time in a row, just 1 year back. We had a GTUG meeting here at GTUG Stockholm. I speak in English because we are now live and direct on the interwebs, internet, how you pronounce it, and this can be found on YouTube later when it's kind of cut and all made up well. So I'm boggled by so many showing up because normally some of you don't show up, and it's really stretching the room to its limits. Really nice to see. We have changed the schedule a little bit. After I'm finished talking, you will have the DICE team, Johan and Jocke, speak about Battlelog and Battlefield 3. Then, because Dart has been so interesting to so many of you, we'll have Florian up of that for an hour, chock full of Dart and lots of your questions. Afterward, we have a surprise, which I don't know anything about really, where somebody will surprise me with apps script, which I think I like. And then we will have WebRTC from Tommy Wiedenflykt, back here also from Google Sweden. And here's, of course, Serge Lachapelle, Program Manager at Google Sweden.
Hi, everyone. Welcome. Just so you know, the setup tonight, we're doing a Hangout in Google+, and we're broadcasting it live to YouTube Live, where it's being recorded. And so people can either join the Hangout or they can watch on YouTube.
And we'll send it here again so it gets a loop.
Yes, exactly. So welcome to Google. Happy to host you. We're going to try to do this a little bit more often now that we have a little bit more space and a cool setup for it. Here at the office, quickly, what we work on Hangouts. So we do the backend servers and backend systems that power Hangouts. We do everything that's Google Talk, Google Chat, the system that Android uses to update the Android market apps. Chrome Sync is powered by Google Talk as well. So a bunch of sync and quick notification systems at Google. And we do WebRTC. So WebRTC is a new project, part of the Chrome team, where you can do add video and audio conferencing to any web page without plugins or downloads. So that's WebRTC is a new API for the web, and Tommy will be talking about it a bit later. So, you know, and this is running on Chrome Canary on a Mac over wireless, so it should work, right? So I'm going to screen share our friend's presentation here, and then I'm going to go back here and do enter full screen, and the floor is yours. Thanks, guys.
There you go.
Hello, we're going to talk about Battlelog. This is basically a tightly integrated web page. Here's the tightly integrated web page with a game. So, where did the idea for Battlelog come from?
Just first, how many of you have actually used Battlelog?
Yeah. Is this mic? I'll just see if this mic's connected. Here, I'll do like this. Here we go. Så alla kan få höra. Ja. Nu. Om du pratar här så kommer alla få höra.
Could we also have the slides?
We're going to bring it back. Like this?
Yep, great.
And wow.
Yeah. So where did the idea for Battlelog come from? Basically, Battlefield is a long-running series, and we have always had a lot of fan sites out there, and we basically wanted to take some of the good parts from the community and basically put it on our own page, and then deeply integrate it with the PC game. So what did we want to build? Basically, we wanted to have a very friend-centric web application where you have like always know what your friends are doing, so you can see if they're playing, if they're just on the website, or other things, and then you can also chat with them, or you can do group chats, and you can always use the inbuilt VoIP as well. both one-to-one and in groups. You will also have available all the stats that you gathered when you play, and you can always look at it into like what is my current status and how did I get here, so you can see your last 20 rounds or so of the game you played. We also keep track of, basically share everything you do in an activity log, so you can see if your friends rank up or unlock new weapons or favorite new servers or write a forum posts or whatever. Then we have basically moved the whole game menu from inside the game into the website instead. So you have your server browser, you have your co-op menus, you're not a single player. You can easily invite friends to your multiplayer games and all that inside the website without actually launching the game. Then we have basically a way for us to communicate with our users. So we have news and also allow people to talk with each other on the forums. So this would be basically a social website. And as you know, those sites, if they get popular, they have a lot of traffic. So we basically needed to build in a way to scale from the beginning. So that was a big goal as well with this project.
Yeah, so I'll be talking briefly about the technology powering Battlelog. This one?
Yeah.
Okay. We use a lot of technology from a company called ESN. They're a pretty small software company. They make a framework called Planet. We also make use of 2 other products and services they make. One of them is Beacon Push, which we use for pushing data from our backend to web browsers. We use a product called Sonar, which is basically a voice over IP plug for the browser. So that Sonar is basically the voice over IP solution used for in-game communication in the PC game. So if you have ever used an MVC framework, I don't think this architecture will surprise you a lot. Planet has a controller layer, which uses Thrift to communicate with a service layer. We have models. We use these models both for database definitions and for generating the Thrift interfaces. And all of this is handled by the framework, basically. So as far as we're concerned, communication with services could be, just in-process communication, basically. We also have a template layer, which is custom. Everything in Planet is custom, which sometimes bites us in the ass. But the template layer looks sort of like Smarty if you've ever used it. But the neat thing is that all of our templates are basically compiled both to Python and to JavaScript. So we can generate, we can render our templates both in a web browser and in the backend. So language-wise, we use Python, Java, and C++ in that order, basically. The Battlelog Web and ESN Planet is all Python. We have a few custom components written in Java. And we also have the plugins and the components within the game that communicate with the plugins written in C++. Using Python, well, I like Python a lot, but using it is also great on our application servers, because basically we have a remote access ports on all of our application server where we simply telnet in and get the Python shell, which is great for debugging and some routine maintenance, basically. All of these features are built into Planet, so we basically simply use them. Planet has support for 2 types of partitioning, both the horizontal and the vertical one. The horizontal one basically means that for each piece of data, each piece of data is assigned to a slice, and certain machines and instances are assigned a few slices, which makes up a shard, which means that we can store basically we're not bound by a single instance in terms of how much data we can store or how fast we can be. Vertical partitioning is basically assigning a service component to a single instance, and that means that if we, for example, have a lab feature which we're a bit unsure of how it will scale, we can simply have a dedicated instance for that component, which means that if that component goes haywire, the only thing it can bring down is the instance it's running on. Persistence-wise, we use MySQL. We don't do any joins. Basically, we treat MySQL as a key value store. The reason for this is the fact that we're sharded and distributed. So doing joins would be pointless because the chance that the two pieces of data you want to join are actually on the same instance is so slim that it's basically easier to just forbid it. We also use Apache Solr for full text search, basically only for the forums at the moment, but we're thinking about transitioning all types of full text search to Solr as well. So beacon push, it's what we use to transfer push messages from our backend into the browser. We use this for real-time updates, for example. So you don't have to have if you have your feed open, you don't need to refresh your browser, obviously, to get new feed items added. We use Flash or WebSockets or long pulling to deliver messages. And the reason we have so many fallbacks is that antivirus software and anti-malware software is basically your biggest enemy if you're trying to do push in a decent way, because some of them will inject JavaScript and modify HTML or XML HTTP request and append a token at the end of each URL, which breaks basically everything. Some of them will block all HTTPS WebSockets. Some of them will block all non-HTTPS WebSockets. And the different combinations mean that we basically had to force Battlelog to use the Flash version of Beacon Push, because that was the only thing that worked across all platforms and all browsers. So that's if you visit Battlelog, you notice that we require Flash. That's basically the only component that requires Flash on Battlelog. For caching, we use memcached. We have great framework support for memcached. So basically, service methods can be cached via annotations. So we simply annotate the type of caching we want. We can also invalidate using the method signature instead of a key, and we can also populate the cache using the service method signatures instead of having to calculate the keys or do things like that. Yes. Yeah.
Yes. So Battlelog needs to be integrated into all the different EA services. So you can use your EA account to log in and stuff like that. So basically we use two main systems from the EA backend. The first one is Nucleus, which is basically the authorization and account system. So we basically, every time you log in, we talk to Nucleus, see if you log in with the correct email and password. We can look up all your soldiers. We can find out which games and expansions you own, or which DLC you bought to like extra weapons or dog tags or whatever. This is pretty great because we don't really need to keep track of passwords or users or anything on our side. So we basically skip all that headache. Then we have Blaze, which is basically the component that the game server talks to, and basically reports stats. It keeps track of which servers are running, all that. And we basically have two ways to connect to Blaze. The first one is event system, which is basically HTTP streaming. So we get notified in real time when stuff changes on the game server. The other one is a simple REST service, which we use for retrieving static data, like stats and stuff. So Nucleus is pretty simple. it's a very simple REST API, HTTP API, and we just do some translations between accounts and entitlements to get basically soldiers and licenses in our parts. So multiple parts of multiple accounts and entitlement stuff may be mapped to like a single soldier or single license on our side. Then we have Blaze, which is, as I said, basically have two ways to communicate with Blaze. The first one is the event system. So basically the web backend, when it starts up, it connects to all the event ports on Blaze and starts listening. The other one is basically on demand. So when we need to request stats and stuff, we do a simple HTTP call and get data back. And if you want to like trace an event, so something happens on game server, that gets pushed to Blaze. Blaze pushes it to the web backend. We may do some translations or invalid cache or stuff, and then we use beacon push to push it out to the web browser. So, for example, if you have you finish the game, the end round is shown. We get that event from Blaze. We invalidate the stats caches and everything, and then we send a notification to the web browser. So we get a little pop-up in the web browser that yeah, you have a new end round report that you can look at. And the whole this chain of events is maybe a second or so from something happening in the game client to being shown on the web. Yes.
Yeah, so yes, we'll mention a few Battlelog features, either because they're something we integrate tightly to our game, or simply because they're interesting from a load testing or a distributed perspective. This is a friend list, or more precisely, this is what you see if you visit another user. You will see whatever mutual friends you have. This friends in Battlelog started out normalized, which is the way we used to do it 10 years ago, which meant that every friend connection was a single row with 2 user IDs. It worked pretty well until we started load testing and scaling up. We also had a lot of problems with caching with the solution, because the problem is that if you ask MySQL, for example, to compare the user lists of 2 users, you can cache the result, but the result is, of course, only valid between these 2 precise users. So what we did was denormalize everything and just store. We have 1 blob per user, which is a packed string of user IDs, basically. So that means that when we calculate this list today, we have to load all of the friends from both users and just do an intersection between the 2 sets. However, this is a lot faster. It wastes some more CPU, but the thing is that popular users, for example, will always have their entire friend list in memcache. So doing this is a lot faster, it's a lot easier to cache, and it's a lot easier to scale. We actually don't normalize a lot in Battlelog, because if you're distributed being normalized basically simply means more pain. We also have a server browser on Battlelog. So if you want to play a multiplayer game, you'll go to Battlelog and fire up the server browser, and you'll see all of the servers that match the criteria you set up. All of these servers are stored in a custom search server built in Java. The reason we chose a custom server is that because we have a few hundred server updates per second, and we also have a lot of search requests per second, and we needed something that was optimized for this precise scenario, which was receiving a lot of updates and being able to respond to a lot of updates at the same time. So we have a custom binary query language, which is designed for minimal overhead, because the amount of data we transfer is actually pretty small, and we didn't want a lot of overhead for simply serialization and passing messages. So it's designed for fast update and fast search, and it works great. We're actually running all of these search requests on Battlelog from a single instance.
So on Battlelog, as I said before, it's basically the front end for the PC game. So as Ivan talked about, we have a server browser, which is a normal thing for a PC game. So you can just filter out the server that you want, and then just select one of them, and you just press go to the server. So the UI for this is pretty simple, but there's a lot of things happening when you press this button. The first thing we actually do is try to reserve a slot on the server. So you want so the time between you actually clicking the button and the game finish launching, nobody else takes your spot. It also enables us to know if you will get into the game or if you will be in the queue without actually launching the game, which is a pretty good thing when it takes like a minute to and a lot of CPU and stuff to load up your game files. The other thing is that we use a plugin. It basically launches the exit of the game client. When the game client has finished starting up, it connects back to the plugin. So we have a two-way communication between the plugin in the browser and the game client. So we can easily do status updates from the game client. So you can show when you're logging in, when you're loading level, all that. So you can push from the game client to the web browser. But as we have a two-way communication, we can also do the opposite. So yeah, if you have press this close button here, we just send from the web browser to the game client. You should shut down now, and then it all happens. So you have full control of the game client from inside your web browser. So yeah, if you want to look this in details, so basically you have the web browser, you have the game UI you saw, you have some JavaScript, you have the plugin, it creates a pipe. If the game client connects to this pipe. So pretty simple architecture. Yeah, as I said before, Blaze has an event system that we use for rapid updates to the UI. So basically, if you play a game of a Battlelog 3, you get a game report. And as soon as the game is finished, we get this report from Blaze into the web. We use this for a lot of things. One is updating your feed, so you can get up-to-date info in your feed about what you unlocked, what you ranked up on that. We also use it for evaluating the caches that we have for your stats. And lastly, we use it to pop up a message inside the web browser that you have a new in-around report to look at. So, yeah.
Yeah, a little, some short slides about load testing. We realized pretty early, obviously, that we did some serious and heavy load testing of Battlelog because we were expecting a lot of users on launch day, and we also have a pretty interesting usage curve on games in general and also on Battlelog, which is that you have a slowly declining user base or not a user base, but the number of peak simultaneous users will be slowly declining from launch day and thereafter, instead of the reverse, which is usual that you have a slow and steady climbing in number of simultaneous users. So we load tested Battlelog using a product called Locust, which is also written by ESN and people outside of ESN as well. It's an open source project. We have tested Battlelog with 2.7 million users, peak simultaneous users, with about 40 million players in the database. And when we do load testing, we always do a pre-pass before we start. Doing load testing at this scale is pretty expensive. It involves spinning up a large number of machines on Amazon and doing the load test. So what we want to avoid is actually starting a big load testing pass and spending a few $100s and noticing that we had a very simple issue, which meant that there was no point in doing a load test, and it was a one-liner fix basically. So what we do is we always do a pre-pass with something called DevBar, which is integrated into planet, and it allows us to for each page you can simply you can view the amount of service requests, amount of database requests, how long they took, and perhaps you need to add an index or make something faster, add some caching. Yeah. So the reason we're using Locust and not some of the other available tools is simply because we wanted to get realistic load testing. Since we do a lot of tricks, like we render some of we render a lot of the templates client side. We wouldn't be able to test that using a normal load testing tool. A lot of the simple testing tools simply hammer a certain URL as many times as it can, which is great if you're testing a very simple API, but it won't work for a large scale product like Battlelog. Locust actually allows for some realistic scenarios. So we can say, for example, that the user visits the front page. It has a 20% chance of going directly to the server browser, finding a game, and then being away for 20 minutes. Or it has a 10% chance of going to the forums and writing 10 raging threads about how pissed off they are with Battlelog, which is actually a very common scenario for our users, at least in the beginning. And we fed these scenarios with data from our alpha trial and open betas. So we try to match them as much as possible. We also, since we're using a lot of external systems like Blaze and Nucleus, we also had to try to coordinate our load testing with them, because we couldn't actually load test using these systems per se, because, well, it's a long story, but we were in different environments when load testing. So what we did do was coordinate our user ID spans, for example. So Blaze would do a load test on their end, which would generate immense amounts of player data using the same user IDs that we used on our end, which meant that our users were actually playing using the load test from Blaze at the same time as we were testing out Battlelog. Next slide. So what did we find? Since our load tests are actually quite sophisticated, we always end up finding a lot of common bugs. So they're actually so close to functional testing that we can use them as functional tests, just running them with one thread basically. So we found a lot of bugs. Obviously, we found bottlenecks. We found I'd say that 90% of the bottlenecks we found were totally unexpected, which is why you should always load test. Don't assume where your bottlenecks are, because they won't be where you assume them to be. A lot of them were actually network related, so things like saturating a single link, for example. So saturating the 1 gigabit link of a memcache machine was pretty common. We could have a 10% CPU load on that machine, but still saturate the link. We also noticed pretty early that you have to keep the traffic within the rack. So if you have, for example, a shard that handles if you have a service instance that handles a certain span of user IDs, we have to have the same, the MySQL instance handling the same span of user IDs on the same rack, because we would max out the links between the racks. And obviously, we also found a lot of software related bugs. And what we did in most of them was, most of them were built using, some sort of best practice, and a lot of the times, we had to throw the best practice away and, just do things more compact, denormalize, do whatever it took to get things running. But in the end, it worked out pretty good. I talked about our templates being compiled to JavaScript as well. We use that a lot. That change was actually driven by the load testing, because doing server-side rendering of every template is extremely expensive. So at the moment when you visit Battlelog, the first page will be server-side rendered. All of the rest will simply be client-side rendering. So what we do is simply, instead of passing the data and the HTML, we simply pass the data using JSON, and then we render the template client-side, and we simply injected into the DOM. And this is also something that Planet, or at least our abstraction of Planet, handles without us noticing. So you can develop, a page as you would normally develop it, and you'd still have support for both, the lazy navigation and the server-side one.
Yeah. So Battlelog integrates a lot with the actual game. So and the game uses basically is driven by data. So you have your levels, you have your stats systems, which basically includes how do you unlock weapons, how do you unlock awards, how do I get medals, when do I rank up, all that. They are just the definitions in a data file. So what we did was basically gather all the output from the pipeline of the game that we wanted, and basically used that input to our own pipeline. So we basically import all the data that we want, put it up in a nice format that you can use. So maybe we generate static Python files, just big bits or sets or whatever, or we generate JSON files. So all of this is basically an offline computation. So when we actually run this in production, we just use the compiled data for everything. This is pretty great because when actually the game updates, we can just get new data from the pipeline and just regenerate all the data that we use on the website. And this happens pretty often in the game when you, for example, add an expansion that we do at regular intervals. We started out basically had this handwritten and did it manually now and again. But nowadays we basically have a pretty automated setup for this. So what are the advantages to doing your game UI in the web page? Basically, it's easy for us to adapt to different devices. We can easily serve the same UI and just adapt it to iPad, or you can run it on a Mac, even if you don't have a game, and look at your stats and all that, or just use the web page normally. It's also easily accessible, so you can easily share wherever you want. You just take the URL and just give it to someone else. So you can show, okay, I played on this web server, or I just unlocked this weapon, or have you seen this these stats I have right now? One thing that also happened pretty fast was that people started writing their own browser extensions and user styles. So they basically added functionality that it felt was missing on the web page by just doing some work in JavaScript in an extension. So it's a pretty good way for us to basically see what people want to have and maybe borrow some ideas for our future development. And it's pretty easy for us to iterate of the UI and easily update it over time. So it's not like a static thing. So in the future, we're basically
came down to the fact they did not have to deal
Thumbs up. It's a future calling.
Yeah. So. Yeah. So basically, having a web page makes it easy for us to update. We don't really need to go through a lot of certification or QA to do like the game does, which basically makes that we can only update like once a quarter or so. We can update every week if we felt like it. One of the big things we're looking into the future is basically big data, which is basically taking a lot of inputs from the game and analyzing them in real time. So you can get a lot more interactive with things like stats and other things. We basically need to add support for future DLC. expansions and new weapons and all that into the website. We're hoping to do public APIs pretty soon to basically allow even deeper customization of using the Battlelog webpage. And a lot of other things that we can't really talk about right now. Yeah, and we also do like weekly updates.
Sorry.
For small things that people get on community feedback. So, yeah.
Oh, sorry. Sorry. Oh, there we go. We're actually having a hackathon at DICE sometime this spring. It will be focused around basically the immense amounts of data that we generate at the moment. Game reports, for example, I mean, that's one example. We generate an immense amount of game reports per second. And if you want to tap into the stream and play around with it, you're welcome to the hackathon. We'll announce it, well, within a few weeks, I guess. But if you follow us on Twitter or just give us your email address or send us an email, we'll let you know when that happens. So the hackathon will be based around our streams. We will also give an introduction to Storm, which is pretty cool if you haven't used it. But you can basically the streams will be Kestrel queues, so you can build whatever you want. But if you like analysis or immense amounts of data, you're more than welcome. So any questions? No questions?
You can ask them questions.
I have a question.
Yep.
Did you think about using anything other than MySQL, for example, since you have social data, like a graph database?
Yes. The biggest reason that we're using MySQL right now is basically that was the only thing that our IT department would support with backups and monitoring and stuff. So that's the biggest reason that we're using MySQL. But we don't really have a big dependency on it. So. Yes.
Compared to the actual Battlefield 3T, how big is the Battlelog budget?
Budget, I'm not sure. We were around, like, at an average, maybe 10 people working on it for around 2 years. So.
We should also point out that we're hiring, so we're about to become bigger.
The only company.
Yeah.
Yes.
Any other questions? No? Okay. Thank you.
Kan ni skriva på de frågorna när de hade hört det så kan ni skicka ett t-shirt till dem som...
Jaha.
We actually work on that, right? Oh, wow.
It works on V8 and Dart.
So anyway, beer aside, now it's time for section 2 of this infamous and world-class Google Technologies meeting in Stockholm. Let's wait soon. And with us tonight we have directly from the rest of Europe, France actually, Florian Leutsch, and he's not in the Google Developer Relations team. He's actually working on Dart right now as we speak. So he's an actual engineer. And so do have questions for him. There might be something for you too. And please welcome Florian.
Thanks. So some small corrections. I'm actually working in Denmark in Aarhus. I just flew here from France. So the Denmark team, the Aarhus team, is the one that is responsible for, or was responsible for V8. So they worked, and I worked a little bit on it for a long time on JavaScript. And out of frustration, sometimes we worked on, we developed Dart. So I will give a small introduction, then show you some code. talk about isolate, which is our multi-threading mechanism. Give some ideas how you should work with Dart, and then talk where you can find it, what open source, where the URLs are, and then give a conclusion. So small introduction. So Dart is a structural web programming language. So it's a new language with new tools, and it's open source. So that's really important to us. Everything we do is developed, at least after we released the first thing in October. Everything is done in open source, in public repositories, or we code in the open. Still, there's a big red warning. This is still a technology preview. We don't want to give any guarantees on stability and API stability. We want to be able to break things if we think that it's better if we change them. So you can already work with it, you can play with it. We do it on a daily basis, but we will break code, we're pretty sure. So, okay. So the current update cool parts. So what we like in JavaScript is that it's flexible and supports incremental development. You just refresh and you have your program running again. It's also nice for small programs, developing small scripts, and it runs everywhere. JavaScript is basically everywhere. And you don't need to install anything. So that's really something we like and that we wanted to keep with Dart. On the other hand, there are some bad parts. Here's a question: how many of you have already coded in JavaScript? Okay, so I should actually not need to say anything for this slide then, but there are some things that are not really working in JavaScript. It's difficult to work for big projects. It's difficult to work on big projects with many people. And there are some types are missing, classes are missing, modules. It's just not working if you want to build something like Gmail or Google Docs. I mean, we can do it, but it's taking us a lot of work to get it right. So what we said at Google in particular said that we wanted to make it better, and we developed a new language that takes the best parts of JavaScript and other languages and tries to remove the pitfalls and make it easier to build big programs in JavaScript. So the design goals for Dart were a structured yet flexible programming language for the web. So we wanted to have a language that is good for big programs, but it is still designed for the web. It should be familiar and natural for programmers, and that's something that many actually didn't like. So when we released Dart, we heard a lot that it's boring. That was actually intentional. We wanted to have something that people recognize and don't need to think about. We wanted something that runs on every device, basically, on a small Android, iPhone, up to big screens, and tools to support that. But let's go to how it looks like. It's an object-oriented programming language, single-based, like single inheritance, like Java. It has optional static typings, and that's something that's probably new to many of you. It has proper lexical scoping. It's single-threaded. In the core, it's single-threaded, and as I said, it has a familiar syntax. So let's try some Dart code. So this is try.dartlang.org, a local version of it. So this is a web page where you can enter Dart, and then it's compiled on the server, sent back in JavaScript form, and executed on the client. Let's write the first small program. So as you can see, the syntax is pretty much C-based or Java-based or JavaScript-based, and we just got the first program running. Let's add some variables. And put that in here. So here you have a small syntactic feature, string interpolation, but in general it's still the same. So far, most of it is still similar to JavaScript or Java even. The main difference is that in JavaScript you can execute code on the top level. In Dart you need to have it in. You need to start your program in the main. You don't have anything lying around. You have to structure it. You have to put it in the main first. That doesn't mean that you can have functions or variables on the top level, but you can't execute anything on the top level. So now that we have a our first function, let's add some classes. I mean, after all, that's what we wanted to have start out with. So that has two variables and a constructor. And I'm going to use a shorthand notation to initialize the fields with the values from the constructor. And I will create a new point. So, and let's print that point. Let's see. Cool. I mean, more or less cool. It worked at least up to the object. Let's add a toString method to make it a little bit nicer. And here I use a small syntax to just return something. And we're going to return a string containing x and y. And now it actually prints 0 and 1. So now let's add another point. We're not the origin. And add a function, a method to space to point class, distance 2, the other point, and let's compute that. Let's hope I'm not wrong. And let's print the distance q and distance, and that's distance to q. It's on my sheet on my screen. Great. Questions?
You have two different ways of defining methods.
Yes, so this is just basically, this is completely equivalent to this. So the error is just a shorthand for returning something right away. Okay, so this is now the first good start. Let's add some closures. After all, we want, I mean, not after all, but that's something we liked in JavaScript as well. And many of us come from Smalltalk and Steam, so there wasn't. Sure.
The call to distance 2, if you have to call it with like x or something, or 0 or some value that
so if I'm running it with if I'm calling it with a 0 like this, so let's just do that. You will get a you will get an exception at runtime telling you that this didn't work, and I will come back to that later to make it a non-runtime exception. Okay, so we have the distance to, yeah, let's add a array. So this is like in JavaScript an array of the 2 points that we have, and let's filter them. Filter, and now we have the shortened form. We have a form, not a shortened, the form for anonymous functions. So the filter one takes 1 point, and let's say if it's the distance to the origin is less than half, we return it. So if the distance, let's add an origin, let's make it a little bit more interesting. Origin equals to point. And if the distance to the origin to p less than, let's make it 2. And then
That's not easy.
that's it. Let's see if I can stop for each printed. Okay, let's see if that works. Great, that actually worked. So we have now filtered our points according to the distance. So this was just to show you the anonymous function, which is here. It's here. So this is instead of having this is basically close to the JavaScript version where you have to write the function keyword and then replace this error with the syntactic equivalent of return. But otherwise, it's just the same. Okay. So now another thing we have in the optional typing. So the optional typing thing is pretty important to us, and I will just now add types all over the place. So we can type these numbers to these values here. We can say the distance to returns a num. And the important thing about typing is you can add them wherever you want, and the program will not behave differently. So the program should, no type annotation is ever used to get a different program. It's only used for verification that the program is correct. And if I go now back to the example that we had where we called distance to with a num, with a 0, for now this should still give you a runtime exception, exactly. But if I add now here and say that the distance to takes a point, and p is a point, then now I can actually flag at compile time. And it tells me that the int is not assignable to the point. So the idea is that you can write your program completely untyped. If you don't want types, don't use them. However, the more types you add, the more static verification you get, and the better your error messages are going to be. You get them earlier. And also at tooling support, you will get more help from the IDE, telling you what methods are on the function, what methods are on the objects, and so on and so on. So in general, it's a good idea to add the types, but you can do it later. So you can start out by writing a small program, 10 lines, 15 lines. When you see that your program gets too big, you can just add the types later on. So, as I said, this is this dartboard, which that's the program, the website. That's how we call the website. Is available on try.dartlang.org. So if you want to play around with Dart, you can just go there. Just know that this is the compilation from Dart to JavaScript. So there are some things that are not semantically correct, but in general, it's pretty good. So now again, back to the types. So a conventional type checker is basically a theorem prover. It makes sure that all your types are correct, and if it can't prove it, it's fatal. In Dart, it's different. It's only fatal if it's basically innocent until you're proven guilty. If the Dart type checker can't prove that you're doing something wrong, it will not complain. And I will now. Yeah. So the idea. So the optional static types are mostly used to convey the intent of the programmer, give some documentation of what you want, get also some early really bad typing errors, get help from the IDE, but it's not, as I said, it doesn't have any effect on the semantics of the program. If you don't add them, it will behave the same as if you add them. And now some examples to show you how not proven until guilty. If you, where can we do that? Let's say that Q, no, that's not it. Let's see. Yes, we get an object here, and then we assign point object other equals O. So, and we will remove that line. If we run now, we don't get any static warning at all. And that's even though we do an upcast here. So in line 5 here, we do an upcast from object to point. Since the prover can't prove that you're doing something wrong, it will just let it pass. So this is one of the biggest differences to, for instance, Java. We don't have any cast operator. You just assign. If the type checker can't see that, if the type checker says this might actually be possible, you're probably right, it will not complain. Of course, if you really like type checking or anything, you can write your own tools, but the Dart language itself will not complain in this case. Let's go back to the. So now a little bit about multi-threading. Aside, we have a single-threaded mechanism that's actually only partially true. It's single-threaded within an isolate. So you have the means to run things in parallel is to have different isolates. And isolates are lightweight units of execution. They run in their own address space, so they have a separate heap. Nothing is shared, nothing is synchronized. If you want to talk to each other, you talk via message passing, so it's airline based. And while it supports concurrent execution, you don't necessarily need to run in concurrent setup. You can actually run them one after another, fair thread-wise, or you can just, like in JavaScript, have them wait for each other. This is now the how do you send and receive messages. The idea is that you have receive ports, the red ones, that can receive messages. And for each receive port, and receive ports live in an isolate, they can't migrate. What you can do though is get a send port for a receive port. This is the green thingy. You can get one or many. And these are capabilities that you give to other objects, isolates that you can give around. And they are a way to send messages to your receive port. So the green send ports are just you put something in and it gets out on the other side at the receive port. And if you don't have a send port, you can't communicate, you can't send anything to the receive port. This gives you a way to structure your isolate in a way that you have a receive port that accepts important messages that can destroy something or anything, and you only give send ports to trusted other isolates, to trusted other objects. So basically, that's what I just said. You have a receive port that accepts incoming messages. They live in a specific isolate. They can't migrate, but you can give send ports to other isolates and to other objects. So let's just look at the small example in the dark again. So this is the current mechanism to create a new isolate. Doesn't mean that it will stay, maybe it stays. But in general, you should not be worried too much because we will probably, or we will certainly add some high-level mechanisms to create new isolates on top of what you just saw. But just to give you an idea of the properties of this, and isolates. If I'm not wrong, I should say isolate. So this is the way we just spawn a new isolate. For now, you can't really see the difference. You could just say this is a normal class. But if I now add a static variable, let's say var equals 9, and if I change that in here, 2, and I print this variable inside my other isolate, you will see that in the other isolate the variable has not changed. The two isolates have two separate heaps. They don't have any way to access each other variables, in particular the static variables. Another thing I will now add is a small print after we spawned the greeter. And you will see that this is actually done asynchronously. So the greeter spawns a new isolate, and then it finishes printing the spawning. And then only when the isolate starts up, we get something back from the other isolate. Now, just because I mentioned the isolate, the ports, I will also show you a small sending back from the isolate. Oh, no, actually not sending back, but sending from the main to the isolate. When you create a new isolate, you get also a port. So here you have a port, and we can just say that it receives a message. When it receives something, it calls the following callback, which will just print received message. And if I now wait here for the spawning to be done, and then I get the port, the send port. Let's make it explicit. P, and I call p.call my message from name. I hope I haven't done something wrong. Yes. So yes, it worked. So we have the greeter. Once it's done, we can. So the then is basically waiting for the spawning to be done. it gets the send port to the other side. So every time you create a new isolate, you also get a one way of initial communication, which is a send port on the spawning side and the receive port on the other side. And we use the send port that we get from spawning to send the message to the new isolate. And the new isolate takes the port that it's created at spawning time, registers a callback, and when it receives the message, it just prints it. And you can see that the order of execution is first the print is done after the spawning, then the isolate is started. The isolate is started and registers a callback. Once the callback has been registered, it still prints the new isolate, and only then it receives the new message from the other side. Okay, that's good.
Reply to.
Okay, that's in theory when you call. I wanted to keep it a little bit simple, but if you do a call like here, you automatically generate a new receive port, which is then sent to the other side. And in theory, you could use the reply to, which is a send port, if you want to type it, to reply right away. But that's just some convenience methods and so on. But in theory, if I run it now, it should still do the same thing. So we have a type check now that this is either a send port or it might be null, but at least it fits into this variable. That reminds me, in Dart, you can't have additional arguments. Like in JavaScript, you must have the correct number of arguments. There are some ways to have optional arguments, and I'm probably not going to talk about them, but you can't just forget an argument or have one too many, one too less. So we actually receive something. Okay. Yeah, so the execution model is more of how you are supposed to work with Dart. So you will have your Dart source, the program you write in. You'll probably develop in Chromium or another browser where you have the Dart VM integrated, so you're just refreshing and running your program and everything works fine. And then when you deploy, you will hopefully use the tools. And there's one part that's the Dart C compiler that compiles to JavaScript, then runs on every JavaScript engine, hopefully, unless we have a bug. And otherwise, you can also create snapshots, which reduce the size of the program and should allow faster startup on the Dart VM too. And I will get back to the snapshots in one slide, I think. So these are benchmarks. I hesitated to add them because for one, they are old. They are 2 or 3 months old, the numbers, but I haven't gotten around to getting newer ones, and I think we haven't improved that much. We tried to be feature complete in the last month instead of trying to push the speed. But it gives me the opportunity to talk about the speed. We developed Dart out of, most of the developers of Dart have worked on JavaScript, on V8. And when we designed the language, we paid really attention to the fact that we can optimize it later. So even though the numbers look pretty bad, especially manifolds here, but even though they look pretty bad, we know that we can get faster than there's just so many things you have to do in JavaScript to be right that slow you down that you don't need to do in Dart, that we know we can be faster than JavaScript. It's just that we haven't gotten around to implementing the crankshift, like the adaptive profiling and optimizations yet. Even worse, it's actually we know that the crankshift-like approach was really successful, and therefore work towards that, which makes the initial thing a little bit slower, but should allow us to be faster when we actually optimize in the crankshift-like thing. As far as I know, this is still faster than the first version we shipped with V8, so most of the people in the Dart VM team are pretty happy with that. The Dart C compiler is the compilation from Dart to JavaScript. In theory, we have to do a lot of more work to run Dart in JavaScript. So you should not expect to have. You shouldn't even expect to have the same performance. On the other hand, there's a huge advantage of having us write the code of the compiler. We know JavaScript pretty well. We have written the V8 engine. So we know what we should avoid when we compile the JavaScript, and we know what we need to do to make the code fast. It's true that we know V8 really well, but most of what we know from V8 also applies to other JavaScript engines. So when we create JavaScript code, there's usually nothing in there that slows the JavaScript down, and it happens that some of the benchmarks in this case, I think it's more, the one 104% speed up is probably just flaky. But we know that some benchmarks are probably going to run faster when we compile it to JavaScript than when you write it by hand, just because when you write it by hand, you are going to do something stupid that you don't know will slow down JavaScript. So we hope to get pretty close to 100. Okay, now back to the snapshotting. This is just this was done again 2 months ago, but it's still valid. We tried to load a program for 54,000 lines of code, and just parsing this thing, it took about 640 milliseconds. And when we stored it as a snapshot, the reloading of this program only took 60 milliseconds. So basically, what you get out of this is when you start up your program, especially for instance when you have your Chromebook or when you're offline or when you just use the cache, your program will be 10 times faster to start up. We don't intend to have a bytecode-like thing that we ship from the server to the client. We really want to have the language we ship. We might have a tokenized stream, which is still basically the language. So this is mostly for cached programs, either the things you have already seen when you run Gmail, reloading it will be just 10 times faster. Okay, this now is a sample application. This has been done during the development of Dart to see if we can actually write programs with the new language if we don't do something stupid. So now let's see if I can get there. Well, give some data first. So this is apparently 13,000 lines of code, even more. But you can look at the code, it's open source. Let's go to the code. So this is a newsreader written in Dart. It is. Let's probably click on something. Let's reload it. Yes. So it's a newsreader. You can move around. You can move up and down. You have different sections, and in some sense it's cheating because we use CSS, but on the other hand it still shows that you can write nice applications in Dart. And what I can show here, but what we showed in other presentations, is we have a user interface for the same program that runs on the iPad and I think also on the iPhone and Android. So the idea here, really the UI guys, the people that wrote this application, they wanted to make sure that they can write programs that run on every platform. Yes, and it's old data just because I wanted to make sure that everything runs. Okay. Yes, you can look at the code. It's in the repository. Another thing that's really nice is our editor. It's based on Eclipse components. It's not an Eclipse plugin. We wanted to get rid of all the things that are not necessary and make it easy to just start with writing code. And the editor, let's start it up. So this is a daily snapshot. So if things break, that's probably normal, but there's also a little bit more stable version of it. It looks pretty familiar since it's Eclipse-based. Now I'll try to increase the fonts. This is my actual working environment. It's quite so small. That's too good. Yes, okay. So this is actually code that I'm working on. That's the Dart to JavaScript compiler. We write it in Dart ourselves. And what I want to show is, for one, that you have completion when you're, at least you should have completion. Yes, it's slow in the beginning. It's Java. I mean, it's Java running up the chip. If I try it again, it should be much faster. Yes. It gives you all the possible combinations. Not combinations, methods and fields. So this is already really nice when you develop. And the other thing that is nice is that you have a way to get from one, that you can visit other, at least you should be able to, yes, you can visit other classes just by control clicking on them, and this way you can visit the whole. You can just jump around. You have a pretty good tool. Okay. No. Yes. Yes, we are not done yet at all. Things that we are working on right now is reflection support. We also think of REST arguments, enums, pattern matching, and so on and so on. We really want to. We know that there's still features that we want to have in, but haven't had the time to make sure that we don't break anything else and that they don't have unintended consequences. But it also gives. But we also wanted to get feedback from the community. So we made a first version that runs that has the basic features, and now we want to propose first and then see what we get as reaction before we put it in. That means that you should give us feedback when you, for one, see something that is not right, and also for features that are missing. And that's a good way to get to the open source project. We have two important sites that are there for Dart. That one is the dartlang.org site, which has some tutorials, the specification, the download link for the editor, some articles which are pretty good. It gives an idea of why we do, how we do things, why we do things. And then we have the Dart project site on Google Code, which contains all the code. And as I said, every code that we write is developed in the open. Before we submit, we have an open source review. We have a review in the open. So it's really, you can follow what we do. As a conclusion, we're still in technology preview, which is bad in the sense that we are going to break programs if you rely on them. If you're willing to fix after some API breakages and so on, it's perfect. It also means that you can still influence the direction of where we are going. Then, as a conclusion, Dart is a structured programming language. We try to take the best parts of the current languages of the web and make it better to create bigger programs. And just try it out and participate. We have a mailing list that is not too active, so you can still subscribe, but we should respond and should know. Questions? Let's go from left to right.
You heard about the compiler, but what about the debugger? Have you got any debugger?
Yes and no. Yes, in the sense that 2 days ago we got the first breakpoints running, I think, or we got it in the Chromium build, so in Dartium build. That's how we call our Chrome-enabled Dart-enabled Chromium build.
It's running tool for the V8 for the Chrome browser.
So we want to have development tools in Dartium, so Chromium eventually, that allow you to even rewrite code that gives you the flexibility of Smalltalk programming. There are many people in the Dart team that initially worked on Smalltalk and that want to bring a lot of that into the Dart world.
Yes, what is the design process like when you're designing Dart? You say you are from Smalltalk and so on. You say that Dart was a bit boring and because you decided to be familiar, but was it a big team, small team?
It was initially it was a little bit bigger, and then we realized that working on a language with multiple opinions, and especially over the pond, so we had other 10 team members in the US. Works in the end. It was, I think, more or less 5 people that worked on it in the beginning, and now it's, I don't know, it's maybe even less because we don't change that much anymore.
And to make it familiar, that was an important design goal.
It was important. We wanted to have something that everybody, especially JavaScript developers, and it turns out Java developers even more, are familiar with. We wanted also something that we can compile to JavaScript, at least in big parts, without too many restrictions. At the moment, the biggest restriction we have is that numbers are compiled, that integers and doubles are compiled both to the number type of JavaScript, so we lose the identity of the numbers. Otherwise, there was a big design decision too, so we have some features that we couldn't get in just because we knew we would not be able to get it done in JavaScript.
And you mentioned, when talking about the debugger, sneaking in some Smalltalk type of
No, the editing on the fly is something that was having a live program where you can just go and switch something that's something, people, they really like the Smalltalk kind of stuff. So, and it's a cool feature. Yes.
You didn't mention anything about testing. Do you have any tooling or?
So, testing is probably going to be a library issue more than anything else. Internally, we have at least 2, but probably 3 unit testing frameworks. Some that are more suited for testing the actual semantics of the language, where you just run small things and compare the output more or less, so you run small tests and then verify that they don't throw. Then we also have a unit testing library that runs that is capable of running in the browser. It is a library issue, and as I don't work on the UI front, luckily I can't really tell of how their library works. Our library is basically just a test of the script, the Python script that runs through a bunch of Dart files and make sure that no exceptions are. But we have, and we want better. It's a question that also comes from Googlers themselves. So we should have good support. Yes.
I'm wondering about the virtual machine. Do you develop it from scratch, or do you reduce what you call the A?
What we use from the 8 is the ideas and the experience we got from developing the 8, but it's rewritten from scratch. You wouldn't want to restart. I mean, we take whenever we can. So we have some low library C++ handlers and stuff like that. I'm not completely sure they're in the 8, but some low-level things like the assembler, definitely. The assembler is taken from the 8 and we copy over. And some other things probably too. But in general, you want to start from scratch, especially when you're
targeting the same platform.
Yes, we're targeting the same platforms. For now, it only runs on x86. Development is progressing on the x64 platform, and then probably the platform. I don't want to give promises, but there are already some ARM files in the repositories. It seems logical.
Yes. I built a pretty complex project in GWT, and I was pretty happy with the performance. And I was thinking about where Dart fits into all of this. I'm guessing the main benefit with Dart going forward would be maybe even better performance in Prometheus, or what is the sort of
compared to Quid?
Compared to GWT, for example.
GWT. Yes. We should have better performance, especially what people don't like about GWT, and it's something where we want to change things, is the cycling of when you want to try a new version, you have to run through the compiler. It takes a huge amount of time, and then only can you run it in the browser. That's the biggest change probably compared to. There are some other things that we changed that made it difficult to compile the JavaScript. Enums, for instance, apparently would be difficult to implement. I have no idea why. And yes, there are some things that are different now. But in general, we want, of course, to run the Dart programming in the VM, so you just click refresh and so. And that's not the case for GWT.
Yeah, I mean, Java has so much momentum behind it and so many tools. So I'm trying to figure out, if there's a really compelling reason for me to get into Dart, other than the minor syntax benefits, and perhaps better, more quick reloading of
the biggest change is probably the reloading and being faster and reloading. If you converting from Java to Dart is usually not too painful, but that said, if you like it and if you're fine with it, I would not change your project that runs in Qt to Dart now. But if you have a new project that you want to start, once Dart is in a more stable version, alpha or beta, unless you're willing to live with packages, I would consider Dart. And I forgot Tifu. I'm supposed to give him away, so after him the next question.
A separate question. You mentioned that it runs on Android, this solution client. So does the browser on Android run Does it run the JavaScript or does it run?
It runs the JavaScript. We don't even have an ARM version of the VMware. So without an ARM version, we can't even try to get it into
tomorrow's work. It'll be done tomorrow night.
Question. Just tell me.
How do you communicate with servers? Are you using WebSockets or?
Yes. So the main, for one, we want to run a Dart on the server too, so that the whole Dart VM is there are people in Orange working on the server side to have a nice API for that. And otherwise, we currently go through the DOM. We don't have any, as far as I know, we don't have any extension.
I think a killer feature could be if you, because I actually played with the dartboard briefly, and I've seen that Google has some pretty interesting IDEs that are web-based. So what about actually building a full IDE on the web for Dart?
That would be great. I can say that.
That was
a little bit too bad.
Will you be bundling Dart with the language, like so make your own
with a what language, sir?
Notation language.
Not JSON. I think we have already a JSON parser. I'm not sure if we're going to have something better, but probably if we have, and maybe we already have, it could be, it would be based on the what's it called, this Google mechanism, the Google things where we send data around.
My team uses JSON.
but internally we have this. Yes, thanks.
What was the answer? Oh yes, of course.
So if we have if we get a binary one or something else, it could probably play something.
I was just wondering if I was just wondering if the idea behind the force mechanism is derived from Go language or
no, we looked at Go, but in this case it's derived from Erlang. So we're trying to get people from Erlang to have a meeting with us, and we had plans one last year, but somehow it didn't work out. But we are going to have a meeting with them hopefully soon, and make sure that we get their experience to have a good Erlang based test. So it's based on Erlang features. So we also want to have the pattern matching, which is very popular in Erlang. It's probably very important if you have a message-based communication. So we are going to borrow some things from Erlang. In general, when we have something that works well outside, we try to take it. For instance, the comments in Dart are now based on Markdown. So you just write your comment not in Java, but in Markdown. Instead of creating another one, we try to take something that is working nicely and looks good.
Yeah, I think isolates and the ports, that alone is the reason to use Dart. That was new to me, and that looks really nice. That was not the boring part.
No, but for us, it serves two purposes. One, security. We really want to have the possibility to, for instance, take Facebook codes and just run them inside a Google web page, but just isolate so that we know what goes in and what goes out. This is something that's very difficult at the moment, and also it gives us parallel execution. So it's not a perfect parallel execution. You will have some cases where you will not benefit from it, if you have a huge data thing that you need to access from every thread. You will always suffer from the isolate. But yes, it's our answer to those two concerns.
Another question in the back there.
No, you have to. For one, because we don't require you to write the types. Yes. The other thing is that it gets very, very complicated because we allow the return type. We allow the return type in subclasses to become a superclass of the superclass. This return type. I think I will go to the no, not here. Yeah. So if you have a class A and you have a function foo that returns an int, let's say, and you have a class B that extends A, then you're allowed to return an object here. And if you have now an A, because let's say that comes from somewhere, then you can't really infer the type of A that's here. Because in theory, you would expect it to be an int, but since the subclasses are allowed to actually go the other way around, as I said, the type system is pretty fine with that. As long as it stays in the same hierarchy, it's fine. You can't infer the type of A that's here. It becomes complicated, and I think that's the main reason we don't want to. That said, since this is static anyways, we are expecting really people to write their own type inference tools and give you better. Even our IDE, we expect it to be better than the minimal requirement of what you get when you have a dot pro. What I also forgot to mention, and that's really important, the type annotations, even though they don't have any effect on the semantics, you can run in a checked mode where every assignment to a type variable is checked. So this is just to let you know. In general, you probably run in production mode where you don't check anything, but you can have a mode where you run in checked mode and verify that everything is actually the way you want it to be. But yes, so we expect better IDE, better support in the IDE, more inference there, even other programs, other tools, but DBM itself, as I said, doesn't even care unless it's in check mode.
One last question.
Yes. One last question.
No, him actually.
I was wondering if when you integrate this into WebRTC and you get to the top, do you do that with the message passing system or another way?
So as far as I know, and I'm not really a dumb guy, but as far as I know, we have one isolate that is allowed to talk to the DOM, so it's not message passing mode. I don't think it's really possible. But we are also working on having a set of isolates to run in the same thread, the same hardware thread, and then even though they don't have shared memory, since they're running the same hardware thread, they're allowed to talk to the DOM. But I'm not qualified to really answer. Thanks.
I have a question.
So I was just thinking, do you have any plans to bring Dart to a non-web environment? For example, building actual Android apps, or maybe running on Google App Engine or something like that.
You're talking to the wrong person. I was one of the people that developed Dart, so I would like to see Dart everywhere. Everywhere.
That's a yes.
So yes, I would like to see the plans. I think for now we would be happy if it goes into Chrome and gets public. So that's
Thank you
pretty
very
much.
much. So I have a couple of questions belong to source, and we'll have another 10 minutes break. And please, Florian, I'm asking lots of questions now.
Please do that.
Some of the teachers.
Are you doing anything in particular? It's a few t-shirts left for me.
Don't think so.
some guys already seen what's happening maybe because of the setup here. But this is Magnus, I'm Robert. Yeah, we went to this app script extra GTUG a while ago. Got some ideas. Then like 2 weeks ago, we had a hack night and did some fun things. So let me show you a problem first of all. This is a mail conversation, and I think it's from the mid of 2010 something. And it's Peter. He's inviting. Yeah, that's Peter.
He just looks like me.
Yeah, good looking. Yeah, he's invited to a GTUG, and yeah. Oops. Weird. What happened with all my translation? Shouldn't matter. Okay, anyway. I had some nice translation because it's in Swedish, so now I have to do it live. So let's see. So Peter, he's inviting to a GTUG meeting in the middle of 2010. So it's about the hackathon that was last Saturday. And then the GTUG mail list got a reply. Oh, sorry, I can't come. I have to leave my place this time for another guy. So that's good, at least someone else could come. And then another email. No, I can't come either, so sorry. And then Peter, he's so nice, so he's answering everyone to the mail list as well. So yeah, okay. See you next time. Take care. Twice. And then the next email in the middle here, someone is asking, is there a list of people who's coming? Because I'm not sure if I'm registered. And yeah, Peter answers, yeah, you're registered. We come. You can come. And then a bit further down, yeah, it's another one. Oh, Peter, do I have a place too? I'm not sure either. So, yeah, pretty usual conversation actually on the GTUG mail list. I mean, you can get annoyed sometimes. I mean, you want to have you want to have it in your priority inbox because you want to like register fast because it's really popular and you don't want to miss it. So, then still. This annoying, yeah, you know. So already then, it was now it's some translation, but the white background is gone. Yeah. Okay, I can't. I'm not really happy with the Google presentation versioning now. But anyway. So yeah, so someone is saying, "Hi, the process for registration isn't optimal. Does anyone know a way to make it better?" And then, yeah, Peter's answers. Is it hard? Or is it hard? Does it give bad feedback? Specify, please. And this guy here replies again, yeah, people doesn't seem to know if they're registered or not. So how could we solve that? And Peter answers, yeah, that's true. How can we improve it? It's a lot of emailing for me as well.
That's right.
Yeah. So, yeah, you know, this is a big problem because you can't even write this JavaScript. That's not fun, right? So, the solution is our little hack here. An event management system with Google App Script that we got aware about on this GTUG meeting. So, we have identified maybe 4 main problems that we solve. And it's like, the registration is full. How do I get in the queue? Because you know people are canceling, so it's still a chance, but there's no way because the registration page is gone. And then how do I unregister? I can't come. I got this deadline, you know. And what's my position in the queue? Do I have a chance, or can I go for after work straight away? And finally, who's managing the queue? Is it you? Yeah, it is. So now Magnus will present you the solution. The solution.
Wow! Yeah, I guess I don't have to say much because it's self-explanatory. But okay, I'll say some things. So first we wrote some just scripts to try out things, and then we realized we could make something big out of this.
we could make Peter have time for his JavaScript and beer and anything else. So we created a Google site, and I could have a script on that too that checks the queue and registration and updates it. And then we created a register form, unregister form, and the check queue position form. You probably get what they're used for. And I don't know how many have used Google Forms here. Yeah, quite a few. So every form is connected to a spreadsheet. So when the form gets input, it's submitted and it's saved in the spreadsheet. And then you can do stuff with it by scripting, and it's using this JavaScript. And when we're going to show you a demo of that. Just going to try to fix the windows.
Is this a widget you've done in Google Apps Script?
No, it's just regular scripts. Okay, so here is our really simple event registration page site, and here you can see that there are two places and no one's registered. So you just go on and register. So we just enter someone here, X. And then we're going to use these fake emails that we registered just for this. And then we submit that. And you can see in the spreadsheet here below, we get that registration. And it's a registration code and a status that is calculated by the script. So let's... Okay, yeah. And here in the inbox, you can see it's the registration successful for the event of the year. And you get the registration code, and here's a link to the unregistration page so you can unregister. The best thing would be if we could create a link so we could just unregister by clicking it, but we didn't really know how to do that. Maybe someone can know about that. And then let's register another one. Here, if we check the page, the bad thing about this, or not, maybe it's probably a good thing, but you can only run this script once per minute. So that's why it's not updating right now. But you can see it updated for the first registration. And down here you can see 2 are registered. And if we check the, yeah, we didn't use that email. Here's my own. So we're just going to register another one. And we should get another one. And here you can see it's queued since the event is full. And if we check here now, it's probably going to say full, since it hasn't run yet. So then we check the inbox here, and you see here you were put on the waiting list. And you can still unregister, of course, but you just have to wait for the. And you can also check your queue status. So then let's say that Mr. Y doesn't want to come, so he's going to unregister. And I shouldn't copy it from there. No, we're doing X, of course. And I shouldn't come here.
Okay.
Yeah, he's gonna unregister here, and then see that he got unregistered, and Du Guangli got registered instead. And if we check the inbox of X, we got the unregistration successful email. Too bad you couldn't come. Thanks for making room for others. And Du Guangli got the, you're now registered and no longer on the waiting list. Congratulations. That's it.
Thanks, guys.
And then, let's see.
I should have done this myself, of course. 7 years ago. I didn't know how.
Yeah, so yeah, I probably missed this slide, but so for you that don't know, Google App Script is a JavaScript cloud scripting language that provides easy ways to automate tasks across Google products and third-party services. And that's the demo I did. And we would be happy if you could contribute if you have any ideas. So, because we put it on GitHub, and yeah, it's not much to see, I guess.
Or if you want to create your own event, you can read how to there.
Yeah. So you can just go to GitHub and fork it, and if you have any ideas, and then send us pull requests. We most likely will accept them.
That's great.
And so for the next GTUG, you will get a confirmation email when you register. Right, Peter?
Yeah.
Awesome. Questions?
You won't get a shirt, but anyway.
What do people do now?
Just drink beer.
And make some more JavaScript, I guess.
Yeah.
Yeah.
And GTUGs more often. Thank you. Oh, sorry.
So I was curious about what is triggering these scripts. So I guess you can trigger scripts resulting from doing things in Google Docs, for example. But what about this other script that you showed us? Is it like a cron job that sort of
it's you have two types of triggers, I think. One is event-based, so at least we have only been digging in the spreadsheets, but you can register one on the form submit. So when someone submits a new form row in the spreadsheet, and when someone is editing and then they have to open it and edit it, you can trigger scripts. And then
yeah, on the site you only have time-driven scripts, and then the minimum is 1 minute. So that's why you won't.
And you can also register when someone is opening the spreadsheet. And then the time-based one.
And you're allowed to send email basically freely whenever you like from Google Apps.
It's probably a quota, but
yeah,
pretty much, yeah.
We haven't
tested next GTUG.
And one thing that would be really neat if Google could fix is if you could cooperate on a script in Word. Several people like in docs at the same time.
Great tip.
Which you probably have the knowledge to do. It's just not done yet, since you do a lot of other stuff.
Like new programming languages.
Yeah.
Exactly. Yeah.
How much time did you put into this?
About 8 hours.
I think. Yeah.
Plus presentation, maybe.
Yeah.
I mean, 8 hours each.
Okay.
But mostly together.
So did you know Google Apps Script pretty well before?
No, we don't do that much JavaScript daily.
Okay.
We're like into the
But it's really
.NET
simple.
and Java world on our work, and then So if you don't not that into JavaScript, it's still easy.
Like you can just use that last line, just mail app dot send email to send an email. It's just really easy.
Okay.
All right.
Thank you.
Well, those It's probably a new window again.
Nope, the same window. So, my name is Tom Wiedenflykt, and I work here at Google. I've been at Google for a bit more than 6 years. And for most of that time, I have been working in the real-time space. So we bought the Luleå company, Maratech, where Serge is from originally. And I joined that team when we Googlified their product. Then we switched to work on adding video chat to Gmail. That involved writing a big fat plugin and lots of JavaScript to interface these two. Actually, it was 2 plugins, one daemon running on the machine and one browser plugin. And that sucks, basically. So right now, I'm working on the WebRTC part where we put all that functionality directly in the browser. So here's a bit blast from the past. So what did Maratech start to do there is to enable collaboration over distance, basically. And this is what everyone had to do then, back then, if you wanted anything to do with video. And it's especially the free first task here, which starts with license, that are both difficult and very, very expensive. And then you have to write the client software, a whole bunch of them. And this brute have an update mechanism, whatever, rinse, repeat. It's very expensive and not something a small company can do very easily, but it could do that. And this is what it looked like. It's a big fat Java application. Improved a bit, start to get somewhere. And then after we bought Google and stuffed up the project and used the expertise we had, we launched video in Gmail, video chat in Gmail, and that was hugely popular. So things start to improve for the end user, but our life become even more difficult. All things improved a bit, and we released Hangouts, who is actually even more popular right now. And this is Vic Kuntra. He is the one leading the whole social effort. He's very happy about Hangouts, as you can see. So there's a lot of companies that do this nowadays, have some kind of real-time collaboration video stuff on the web. I mean, Facebook uses Skype technology, and both Google Voice and video chat and Hangouts, they all require a plugin, and most of them require Flash, which is both clunky and not very efficient. It's getting better now with the last release of Flash, where it actually is a bit of hardware acceleration in there. Still, the front end is JavaScript. and you need a cloud for still signaling, etc. So here's a bit what's really hard is to have the plugin on all these platforms, on all these browsers, on this matrix. And we found that if we want to render VGA quality video, we have to ditch Flash because it wasn't efficient enough on most platforms. So we have our own rendering technology in those browsers that support it. And surprisingly, the biggest difficulty we have in enabling video chat and email was getting people to install a file.
They can all download it.
Yeah.
But they can't find it after they download it.
And if they find it, what do you do with it? So it's a lot of coding, testing, troubleshooting, whatever. And this is the dream we had a few years ago. What if everyone could use this? And if you want to realize a dream, you have to start finding out ways to make it possible. So we started by actually buying a company, a second company in this area called Gibbs, who has a very nice codecs and echo cancellation, etc. We took most of their code base together with a big chunk of the code base of the Google Talk plugin, merged those two, and open source it. And oh, I forgot a company here, Mozilla and Opera. They support this feature, and so do Ericsson. If you saw the news just the other day, they had made a demonstration, a browser on iPad that ran WebRTC. So that was really cool. But doing something without standard support is kind of useless. You never get the industry support that a feature like this need. So we have also dedicated a lot of time in the different standardization committees, working together with them, giving support, actually having a guy whose full-time job here at Google is to make sure that all projects that should is involved in the standardization process. The drawback for that is obviously that the spec changes because there's a lot of strong people with strong mills. And me and other people at other companies who actually have to implement it has a constant flow of work to do. But that's the other side of the coin. So here is a bit more in detail. So the top gray bar is the JavaScript API. And that's our effort in this space involves working together with other people in the WebKit community to enable WebKit to use these APIs. The much bigger chunk of code is the library that we have open sourced and that you can find on webrtc.org. So you get a world-class codec, get both for audio and video for free, basically. You get all the transport ISTAN stuff as well in there. And obviously we have it's not just that we are very nice to give this away. We are doing this because if we make something good and give it away, it's going to be really easy to implement this feature in as many browsers as possible. So we really want this to be a good standard and that all browsers have it. And also the major dream here is to do stuff that nobody had thought about before. Not just standard person-to-person video conference call, but whatever. And so, next step in a while is write, publish, profit, end up on TechMeme, get famous. And here's a bit of how the WebRTC works. I don't know if there's a standardized symbol for a computer, but Google Docs sure as hell doesn't have anything that looks like one, so I use smiley faces. So if you start with the middle and up, you run your JavaScript on the end user's browser. You got to provide some way for the users to find each other. So you got to have some kind of server, even if that server is very simple. So to be able to set up a real-time connection between two computers, they need some way. Can be slow, whatever, doesn't matter. But they need some way for the two people to send out details about each other, so they can find each other through home networks or whatever. So that involves sending a few candidates back and forth. I can do this video, I can do this audio, I can do this resolution. I'm behind the NAT, I'm not. Okay, well. In later versions of our library, we will add proper support for turn servers. And that's also something you have to provide yourself if you want to have really reliable service. Or you might get that for free or for a fee from us. We haven't decided at all. I'm coming to what a turn server is. So what a turn server is the last resort for if two people are sitting behind a NATed home router, and both are really shitty ones, they don't even have universal plug and play, nothing. So there's no way they can start talking to each other. Then you can use a turn server. And both clients find no DICE, so they both send the data to the turn server, who just relays the video conference data or the real-time data between the two clients. Adds a bit of delay and a bit of cost, but that is unfortunately needed today to get 100% connection rate. And yeah, that's the end of the presentation. So let's do the fun stuff, demo. So we released this in Chrome just a few days ago. And just overnight, lots of people started doing cool stuff with it. And this
you have to shut off Hangouts. Oh no, it works.
Yeah, it works fine.
That's the other camera.
Yeah. So this application is using the API, but it doesn't use the peer-to-peer stuff. Just the local, get me the camera, get me this data, and then render it in a video tag. And then it uses WebGL to add cool effects. This is all running in a standard browser. However, it's a canary browser and only works in Chrome right now, but it should work in Firefox pretty soon. So this is just pretty awesome what you can do.
Just JavaScript. No downloads, no plugins, no Flash, just JavaScript.
Does he use lip sync?
This stuff isn't using lip sync, no. But
the API,
if you use the peer-to-peer connection, then we try to do lip sync as far as possible, unless there's too big jitter or whatever. And a colleague to us wrote this application, which you can test for yourself. You just go to this URL. Okay.
Thanks. I think that now the Hangout is fighting.
Yeah, I think we lost access to the camera.
If you... What do we do about the Hangout?
No, it doesn't matter.
Where is the Hangout? Oh, it's there!
I think it's better to...
Let's just stop the camera. Will that work? Or if you switch it to the eyesight, I don't think.
No. Oh, he's using eyesight.
There. Try that. That was the one part I didn't think about this.
And where's?
It's probably in the.
No, that's the Hangouts.
Okay, just minimize that one. Minimize that one. There you go. Reload. Or kill the Hangout. Sorry, guys online.
It doesn't matter. We just leave this. And this is the basic site. If two people go there using the same URL, they can start chatting to each other, and that's built upon App Engine, just the server.